So Joel was telling us about taking things out of the ground, and I think Tanner's going to tell us about putting things into the ground, giving us a geotechnical contractor's perspective on the subsurface.
I must say I've followed a lot of presentations before, and that one's probably one of the more fascinating ones I've had to follow, so I apologize for mine being boring. Again, I'm Tanner Blackburn. I'm the Vice President of Engineering for Keller Foundations, which is a group of several geotechnical contracting companies who operate all over North America. I was asked to kind of discuss as a geotech, especially contractor perspective. It's fairly difficult in 10 minutes, so I'll do my best. I wanted to kind of get to how we're using data now in several different applications, both data of what's in the ground, data of what we're doing, data how it's responding. But again, for urban construction here in the cities, all the cities in North America or all over the world, these are some of our typical applications that we see as a contractor, as a geotechnical contractor, where we are called. It's just always important in urban environments to remember that everything around it is interactive, right? So everything we do, whether it's excavations or foundations, there's typically going to be a utility or building nearby that's going to be influenced. So that's our main risk, other than obviously health and safety risks to our people and other. How do we use the data that's out there right now or in the future to mitigate our risk as a geotechnical contractor? The first thing, as I mentioned, is it's important to know what's there. And this morning I had several great examples of the growing techniques there on knowing what's in the ground already. How do we avoid it? What are we doing currently in the ground? That's another new field in data acquisition and data management. Is we now are in an initiative to put sensors and data acquisition units on all of our drill rigs in North America. That's something like 500 pumps and drill rigs in the continent. Each of those collecting maybe 5 to 6 data streams as we're working. So that's an enormous amount of data that's going on. What do you do with that to mitigate your risk, make sure you're doing quality work? And then again, observing the response structures nearby. I wanted to focus on 3 examples of our technologies and where data has kind of come a long way, I'd say, in the past 10 to 20 years on mitigating risk in urban environments. The first, we saw many other better photos of utility locates earlier in the session. But again, I wanted to point out that further we can go in that in databases, accurate modeling or accurate representation of what's in the ground in 3 dimensions, the better off we all are, because the running joke is that Hayward Baker, one of the companies that's owned by Keller, we used to call it the Hayward Baker Utility Locate Service, because every time we'd get up on a job, we'd hit something probably. I mean, to this day, we have policies where we call utility locates. We cannot start work until we do a utility locate. And I would say once every 1 to 2 weeks, we hit a utility. Even that's painted on the ground, even that's potholed, it's all about the data, how we know it's there. And this is how we do it. We try to incorporate some of these 3D AutoCAD models that are provided, and unfortunately, they're not provided very frequently. We'd love it if they were. We have the resources to incorporate them into our construction planning. So again, you can see a fairly complex excavation support system that was designed. This one's up in Illinois. This one is in Atlanta, where we have several utilities, wastewater treatment tunnels coming through. All of those, we're snaking anchors, ground anchors, through a network of utilities. So again, when we do data acquisition or we do utility locate data, it's important to know that the accuracy is key, because as much as we want to paint them on lines or paint them on drawings, if they're off by a couple feet, that's inadequate for us. We're missing these by 6 inches to a foot by design. So as pretty as the pictures can be, they've got to be representative. Again, the focus on GPR is getting better and better, and that's becoming a tool not only in earth retention, but in all our foundation systems, because we can use it to identify voids or unmarked utilities in working platforms to ensure the stability of our rigs. Another use of data then, that was an example of what's there and knowing what's there and how to mitigate our risk by avoiding it with drilling anchors or putting in piles. Here's a case of what's being done. How do we work with data? Nowadays, this is in the past 10 years, the LiDAR, the instrumentation that's available now is just immense. And so we are able to monitor structures as we're excavating next door to them and see how are they reacting. Are we able to change our designs? Are we being too conservative? Are we being too aggressive? on our excavation sequencing and our anchor performance, or bracing performance, stiffnesses of our walls. So there's kind of a feedback loop here, as you can see, that where we are able to come up with models initially, observe them with the data as it comes in. It's important to be able to have a good system in place, and then modify our design or modify our construction procedures accordingly. So that's one of our uses of data nowadays. And this is, again, a growth that's happened since I was in the past 10 years. This data is so available that there's really no reason not to require it to be used during construction. Here's some examples. For example, a structure or an excavation with 3 structures nearby. We have automated total stations. We have in-place inclinometers. None of these are being read by humans on the site. These are all being read by humans on computers in the office or emailed. And that's a huge change. That's in the past 5 years. I think that's become a commercially viable option for structures in urban environments. There's no excuse not to require monitoring in real time on these sites as a mitigation risk mitigation activity. Another technology that's common in urban environments for ground improvement is compensation grouting. Compensation grouting is it's hydrofracking. It's the awful word of fracking, but this is kind of a good fracking, I suppose. So when you have tunneling or excavation support systems going into place, you can see on the right, that tunnel, when you have some losses due to your excavating of the tunnel, current structures want to settle a little bit, right? Depending on the workmanship, depending on the method, depending on how close that structure is to the tunnel, it's going to settle. So what the idea is, you install a whole bunch of series of pipes, and you just grout through ports in these pipes, and actually jack this. These are all drill holes, each with grouting pipes, and you inject a fluid grout in there, very targeted, to respond to this, to have that structure respond to the tunnel as it approaches. So when the tunnel's coming up and you observe a little bit of movement, you're able to actually hydrofrack or jack the building up. Again, this requires some pretty good workmanship and data collection, because you can't just go jacking up structures all over the place, or you'll actually do more damage by lifting it. So this has been done in almost every city that you can think of. These are ones that I've been involved in with Keller. I know that there's some with other companies all over the place. Houston, here in New York City, and Washington, D.C., you name it. So the key is it's a nice technology for existing sensitive structures, because you do not have to drill through them to underpin them. You do not have to, through the foundations. We use them for, especially in Europe, foundations that were built on, say, cobble or rock foundations, not a poured concrete or brick foundation, because you cannot underpin something that's founded on rocks, cobbles or loose bricks. So we jack it up. But the key here, again, is the sensitivity to that, because we have to know when the tunnel's coming, what's happening, be able to know what we're putting in the ground. So you can see this is one of our plots of looking at instrumentation as it's happening, nearby structures. We've got pumps that are all very well instrumented on how much pressure, how much grout, going where in this command center. And we're able to watch, a TAM is a point where we inject grout. We're able to watch the settlement, is blue and white. That's the actual structure. And then we're able to watch what we're putting in the ground at the same time. And those two have to be married together. So this kind of technique is really neat now with the amount of data that's available. Another technique that we do that's common here, and actually very common here in New York City, more relative to a lot of other cities, is jet grouting. And again, this is used for underpinning structures or doing earth retention next to structures that are very sensitive. What it is an erosive technology. So you drill in the ground with a drill bit, and it's called a monitor. And we inject with water or grout fluid under high volumes, high pressure, high velocity. And you're essentially eroding a column. And then as you're eroding that ground, you're injecting cement at the same time, or cement grout, and you're forming a column in place. What's nice there is we can make a 10-foot column without having to drill a 10-foot hole. We're drilling a 6-inch hole and creating a 10-foot column underground. And it's done for earth retention. This is in Berlin. This is underpinning the Berlin Symphony Orchestra Hall, or concert hall. Again, where you don't really know the foundations, you need to do an excavation next door, you're afraid any driving of sheet pile or any kind of drilling of a wall is going to cause settlement of that structure, disturbance of that structure. You can do it for tunnel crossover passages, where you don't want to treat from the ground all the way down. If you're 80 feet to the ground, you just need a little cross passage. So you can drill and create this soil creep block and drill through it. The problem is, when we're injecting this stuff this is a pressure washer that you'd use to clean concrete, but it's on steroids. The pumps are the size of a construction trailer, and they'll cut your hand off, right? That's how much pressure it is. It's 6,000 psi. We're injecting sometimes up to, we're injecting about 100 gallons per minute in the ground for some of these cases. So if we're underneath a sensitive structure and you're injecting 600 liters or 100 gallons per minute, 150 gallons per minute, and the material's not coming back up, or the erosive material is not coming back out, that means you're injecting 100 gallons per minute somewhere that is then just going to heave everything up. And we've heaved some very sensitive structures, so what's required there is that you monitor the structure. You monitor what you're doing. Now I need to get forward there. So what we do to mitigate that risk of making sure the material is coming back up is we watch how much is going in, and we watch how much is coming out. We watch nearby structures. Like on the right-hand side here, we put tilt meters, settlement gauges, total stations on there, and these are in the operator's cabs. So they're not read by an engineer, me, later on, 3 days later. These are read as it's being injected. So this data is in the past 5 to 10 years has been available, and it's just fantastic for urban, sustainable, for working on structures that are very sensitive. Because usually I know about these 2 weeks later when we get called by the owner and says, it settled about a half inch or something like that. But again, the data is there. The key is just how do we work with what's in the ground already, knowing what's there, the utilities, what's knowing what we're doing here in the center column here. We have so many sensors now on all of our rigs, and most of our competitors, I don't mean to say Keller, but all of our good competitors do the same. It should be an industry standard. It's getting there. Are able to watch what they're doing at any given time. And then now it's becoming an industry standard to watch everything around you as a contractor. Make sure we're not doing damage. You don't want to do more harm. So those are the 3 techniques I could think of for urban applications where data is handy. I'm around the rest of the evening. I'm happy to talk to anybody. Thanks for having me.
Okay, so we have a few questions for Tanner. So you showed a picture of compensation grouting. So obviously we're putting stuff into the ground that's not super well defined. It's not a pile. It's not a tunnel. It's not a pipe. Are you guys doing anything to document that is in terms of an as-built for future projects and what's going to happen 50 years from now?
Yes. So we do as-built all of our pipes. So the pipes stay in the ground.
Yeah.
And for certain environments, they request that we have PVC pipes rather than steel, or fiberglass if you really want to pay money. But and then the grout is actually a fluid grout, right? And so when you inject it, it becomes a spider web of lenses, and we track the volume of what's in the ground for each point at each square meter. So we do know that you would have in this X square meter this much cement grout.
So that's obviously changing the mechanical properties.
Absolutely.
It's strengthening it, which is what you want to go fill the voids. But my question is that becoming then part of the as-built drawings that are then going back to the owner?
Not yet. Well, not in a systematic way.
Okay.
Right? Some people will want our as-built, but I think in the U.S. here we're fairly behind on, say, BIM stuff versus other locations.
And so speaking of data standards, so are you guys engaged in any of the things that we've seen earlier today in terms of storing your own data, in terms of using a DIGS format or an OGC MUDI format or your own format?
No, we're not. Well, no, we're
Okay.
not. We store our own data. We provide it as needed under contract. We have worked with Alan a little bit on the DIGS stuff. We have people participating in GI and stuff. But,
And can you give the audience a bit of a sense of, when you talk about the quantity of data, how much data is being produced on a good-sized job?
Oh, for example, a jet grouting job, gigabyte a week of stuff. It depends on how many shots you're taking, whether you're monitoring around it, or recording instruments. Again, it's someone's got to look at it to make it worthwhile. That's our problem.
And the last question we have for you is, have you all tried to use terahertz scanning as an alternative to ground penetration radar? Okay. All right. So thank you very much, Tanner.
Thank you.